because I know you've gone through that. Like if we're to give an equation of a straight line, maybe say I said, guys, listen, I'm giving you y equals to mx, and then I'm saying mx plus c, where m and c can be numbers. And I said, okay, this is rectangular. Can you do it ka polar? Ka polar mona ki r sine. So that means I'll be writing it. This is r sine of theta. And then kingwale m, monaling x, ki r cos of theta. Do you see what I'm saying?
Oh, yes.
And then plus c. And then I can do whatever I want to do, maybe kicking to n, but I can even leave it here. Or let's take this and bring it over, because normally they love to solve for r. So you've got r sine of theta, and then minus, I'm going to write it as mr, and then cos of theta, because I just took straight line. So that means every equation, straight line, parabola, hyperbola, cubic graph, you can change them. Equation of a circle, you just replace x with y. So common factor iba r, then I'm having r into, and then sine of theta minus m, and then cos of theta, all of that equals to c. Then I must divide, I must solve for r. So I'm having c all over sine of theta minus m cos of theta. So that means n, it's a form of straight line using polar. Can you see that? Yeah, so every time when you do that, one equation can be simpler than the other. We are not saying polar, it makes things simple. No, sometimes polar, you find that in a polar form, it's very simplified. Sometimes in a rectangular form, you find that it's much simplified. So you kind of switch between the two and see which one looks much nicer than the other one. Okay, I think you got the gist. I can really parabola, you're going to do the same thing because you'll be given as y. Let's just write it as x squared here. So which means koko y notorki r, and then sine of theta. More x squared dimola, which means ukenya r, and then cos of theta all squared. Then that's it. You can now solve for r from that one. Do you see it?
Yes.
Okay, perfect. All right. So more that I think there was another question, Mona. The other one, well, I just did something similar to this. Come on.
Yes, you did.
Yeah, because 3km for 4kc. So we can just go back here and say, okay, 3km. So that means you'll be putting 3 here.
Yeah.
And then the 4 will be right at the top. Yeah. It will be in that form. You see that?
Yeah.
All right. So that makes sense. So I don't know. Maybe let me just check. The other one you said, yeah, you see, they give you R is just a number. And you can handle these ones. Or we can go through them and then delete this one just to do that. Okay, let's take this one. R equals to theta equals to 2. Can you see? It's like when they were giving me, all right, fine, no problem here. So let's just go there. So they're giving me R, I'm going to make a nice space there and says equals to 2. Remember the polar, normally we always have this. If you choose X, R cos theta. So they gave you a small piece of it, a small part. Do you see that?
Yes.
Or on the other one in a link sign. So what's missing is the cos theta or sine. It doesn't matter which one you use, whether ki cos or ki sine. Where now you just introduce cos or sine on both sides. You understand?
Mm-hmm.
Right. Either one. So let me duplicate that one. But mostly we love the cos. But I'm going to, but later delete 2. No, okay, this thing, kita multiply ka cos theta both sides. Cos theta here. Can you see that?
Yes.
Yeah, so that means you are introducing the cos of theta. And then the other side, somebody said, why do you use cos? How did you know to use cos? Well, I could have used sine, doesn't matter. And the mona necklace is a sine of theta mona. And then the other side, give multiplier cosine of theta. So now you can see enaki x has yon.
A.
Yeah. And then enaki y. Can you see that?
Yes.
All right. Then renali x equals to 2. And then renali cos what is it? Renali cos of theta. And then the other one, somebody natlabanali y equals to y equals to 2, and then sine of theta. All right. Now, normally we don't want to have ntungena. Kanake.
The trig
Yeah.
function.
Yeah. Can you see that? You don't want to have trig functions. But in my mind, I can let me show you what I'm about to do here. It's because these guys, ki 3, the third one, inalidi squared, ki r squared, x squared, y squared. So if you see the other one needs to be removed, like for example, because haribata rectangular. Okay, I didn't even read the question. What is this?
Convert to Cartesian form.
Oh yeah, Cartesian form. Yeah. All right, fine. So that means cos theta utsanse atsamai. I don't want to see the r. I don't want to see the thetas. Isn't it right?
Yes.
Yeah. So maybe you can decide and say, no, let me square both sides to introduce the Pythag, that squared part. Do you see that?
Mm.
Yeah. And then you might say that. Now, in my mind, one thing I was thinking to square more, square more, and then give a little into yeah, because somebody might say, okay, if I square that, and then I square that, it looks like kinali x squared equals to 4, and then kibali cos, what is it? Cos squared of theta. Do you see that?
Yes.
All right. And then the moment you see that ena, we can replace it haribataka. Okay, remember Pythag renali. Okay, let's just write Pythag inali k r squared equals to x squared, and then plus vy squared. But check what if I were to remove this one. If nekiriki replace x squared, that means I'll replace it by r squared plus y squared, which is what I was thinking. I wanted to square Kamo, and then I square the other side as well. You understand what I'm saying?
Yes.
All right. Of which one?
Yeah.
Yeah, because that cause it will back mama that number in your root. Because all right, fine, because I didn't want to go x squared equals to r squared minus y squared, because it's basically the same thing. I can square that one. Ibe y squared mona ibe 4, and then mona ibe sine squared. Can you see that?
Yes.
Yeah. To make Pythag, I have a choice. I can simply, with these two guys, I can simply add them. Kibeli, in other words, y squared plus my x squared. Hakiri kopa. then ke ba le eng, ke ba le 4 ha ke re ne? Cos squared of theta le plus 4 and then sine squared of theta. Well, you know ke 4 mon. Come on. Don't you know it's for the other side?
Yes.
Yeah. You're not lost, are you?
No.
Okay. Then hanka kenya 4 more. So if I stop here, wabona mo unali equation of a circle. Can you see that?
Yes.
It's centered at origin, but then this is r squared. Radius ya yona iba 4. Now think about this. What if you wanted to take, let's say, 2? Would it divide? How do you divide that? You're still gonna have a chord, you're gonna have a tangent. The theta will still be there. If you multiply them, you make the product, you're still going to get twin. Yeah, you're still going to get that. Now, because ki edilemon, or why did you have to add them? Well, I could have just done this. Okay, let's replace this r squared, x squared. X squared ya rona, netoba r squared minus the y squared equals to that 4, and then cos squared of theta. And then if you transpose how it lisakamo, you can see r squared ya gago. Can you see why I was adding? Can you see that? Because it plus y squared key, and then iba plus 4, and then sine squared of theta. Can you see that?
Yes.
Yeah. But r squared, ramtsibar ki x squared plus y. I could have squared the area to get a 4, but next some but it not offer 4 equals to 4. You're like, oh, okay, fine. Okay.
Yeah.
I hope you
So
got that.
the answer is just 4.
Yeah, if you replace this by the r squared, yes.
Okay.
But the r squared, remember, can be written as r squared ki x squared plus y squared.
Yeah.
Yeah, haki bataka rectangle. I must write, it's basically write it in terms of x and y.
Okay.
Yeah, so because r squared, I know ki form, netloba form equals to 4. But these are just numbers. Hanka itwela inali r kappa theta, sine or r and theta. Let's put that, because theta will go with the tangent, cos, whatever. That will be polar. Then say the question is, can't I replace these guys ka x lin twin and y? Can you see that? Can I show you another shortcut?
Yes.
You'll say, why didn't you do that already? Ba go feel or r ya gago equals to 2. Am I correct?
Yes.
Then I square here. Then I square here. Then I'll say, wait a minute. I know what is r squared. R squared ki x squared. And then plus y squared.
Plus y squared.
Equals to 4. Can you see that?
Yes.
Yeah. Which is exactly the same thing we got. But I wanted to show you can recreate it, because other ones, they needed to do that. Others, you can square for the second time. What do I mean square for the second time? Let's say you square it. You square it, ubali r squared, and then hubeli, let's say, equals to r. You say, okay, this guy, I can replace it, that one. You say, okay, x squared plus y squared equals to r. Can you see that? Yeah. And then You say, but I still have the r. The only thing that we have to replace kr squared. So that means I need to square this. I also need to square that one. So that now I've got x squared. I don't have to FOIL it. You don't have to. And then iba r squared, then iba x squared, and then plus y squared. As long your equation in only two variables, x and y, either one or both, x and y. The r is gone, the theta is gone. We good, no?
Yes.
Yeah. Okay. Let's just check. Okay, the other one, yeah, wabana inali x y, so it's already rectangle. It's a pole. So that one should be straightforward also, because we've got y squared equals to 4x. Y, we know it's r sine theta. So I've got r sine of theta, put it in brackets, I must square that. And then this one must be 4. X is r, and then cos of theta. Then the other side I've got r squared, and then sine squared of theta. And then the other side, it will be 4r, and then cos. R, we know it's always positive. Then I can divide, I can get rid of r. I can divide ka r. Can you see that, both sides?
Yes.
Yeah, because I need to keep the r and the theta. So which means that r can cancel, can only one r. That one is gone. Then I've got r equals to 4, and then cos of theta. And then all over this sine squared of theta. Well, I'm leaving it with cos because we can make it either cot or tangent, but I'm going to leave it cos and sine because normally that's what we're dealing with. And then that will be the thing. We sharp neck?
Yeah.
All right. I don't think are they crazy in these things now?
Not really. It's just all new.
Yeah, it just replacer eggs. Y. Kappa replacer the other thing. Here's another thing. Here's another one. This one, it's like one of those little bit crazy yana ones. These ones here. These ones here. All right. Let's give this one a shot. This one. So this one says to us, renally, we've got r equals, so we're making it rectangular, and then cos of theta, and then plus the 4. All right. Now, one of the things you wish for, you're like, oh my gosh, if I was to replace that cos theta, I would have loved it if non ali r mona. Do you see that?
Yes.
Or you would say, if I was to replace that r, I would have loved it if it was r squared. Then I can put x squared plus y squared. So we can have both at the same time. We can multiply both sides ka r. In other words, you now have r squared equals to 4 times r, and then cos theta. You see, when it comes called contingena, ko r, li x, the r, you want it squared. If you don't want squared, then you can use square root, it's fine. Then this guy, I know that guy. Yes. That guy is x squared plus the y squared. And then I've got 4. Whatever it's in the box is the x, isn't it?
Mm-hmm.
And then plus the 4r. But we still have a problem. That r needs to disappear. So what I can do, I can take this 4x I at the other side there. And then I'm going to write x squared minus 4x, that part. And then I'm going to write plus vy squared. Now, let's just say I wrote equals to 4 only. You will recognize, Hori, what's in the yellow box. It's an equation of a circle. Do you see that?
Yes.
Yeah. Now that's so I can choose to write it in that form or keep the way ilinkate. Can you see that?
Mm.
All right. All right. But now let's put the R so that you can see that. Then you'll be like, okay, how do I get R? If the R was actually squared, so don't times everything by R, rather do this. Why? Because if you times by R, the R will now begin to appear also there. Can you see that?
Yes.
Yeah, we could have done so in the other one and raise it to the power. Like how we did the other one, we just raise it to the power. So if I raise this to the power of 2, okay, let me remove that other R, and then I raise that one to the power of 2. Then the left-hand side, it's 4R squared, correct?
Mm-hmm.
But R squared, you know it, kx squared plus y squared there. And then I can only copy what's on the left and bring it down there. So more that last part, there is no theta, there is no R. I know somebody will say, well, I can just simplify it and what. You don't have to. It's already fine. It's already fine as it is because only x y fell. Are we good on this? How it looks a little bit crazy that way.
It is crazy.
Yeah. All right. So now let's do let's work with these two. Sine theta is pi or 2 pi. That one there. Because the other one, they were giving you just the R. Okay, I said theta equals to pi all over the 2. Now you'll be like, no, normally this thing must have R cos theta, whatever. So it's fine. So let me write it again. Let me space it out. I'll put a theta here. That's why I call it reforming or recreating. And then because these two are angles, I introduce cos of theta both sides or sine of theta. Actually, I can say R cos theta, but do it one piece at a time. So if I introduce cos here, I can also put cos here. Key angle. This one, even angle, is no longer a number. You get what I'm saying? Okay, let me give an example. Hakinali R equals to 4. When you introduce cos, you are not doing this. You are not saying cos of R and then cos of 4. No. Those are not angles. Those are numeral. So that number must multiply cos of theta. And that number must multiply cos of theta. Do you understand the difference now?
Yes.
Yeah. Okay, fine. And then the next thing we say, we're like, okay, guys, now we want to put the R on both sides. You multiply by R here, you multiply by R. Now this one is now X. You now have X equals to R times. Now pi ki 90. Now cos, what is cos of 90? It's 0, isn't it?
Yes.
Yeah, then I put 0. I put 0 there. Then I end up with x equals to 0. So that means that's the equation. That's it. Because there's no longer other guys. When I draw x equals to 0, x equals to 0 is going to be my y-axis. You remember? Going up and down. All right. So we can verify it if we want to. This one. And so, okay, let's verify that. All right, because remember your angle keying, they say theta key 90. Like last time I was putting a dot, I said, okay, if you're standing there by the white dot, you must look in the direction of 90. So the white line, it's just to show the direction, not the length. That's where you're looking. You're looking up there. So now I need the length from the dot. How many spaces should I go up? Since there is no R specified the length, you can go all the way up to infinity. And can you see that line? Can you see that?
Mm-hmm.
And then you can also go all the way down to infinity, which is that blue line. Can you see? It's still the same thing.
Yes.
Yeah. Same answer. All right. So I think the other one you can handle it. It's about almost similar. All right. It's the theta pi. You could have used sine, but cos it's also good. Okay. Let's see this one if we can do theta equals to pi equals to angle. So now if I introduce the cos, I can write cos here and put the cos there. Then introduce the r, introduce the r as well. Then I can see the other one, kx equals to r times cos of pi. What is pi? 180 degrees. Am I right?
Yes.
What do I have there? Is it minus? It's minus 1, eh?
Minus 1.
Okay, so that means the r iba minus 1. I mean minus r, so to speak. Resharp, ne?
Yes.
And you see we've got a problem. We still have the r existing.
Yes.
The only way to get rid of r, he should be somehow squared. So I square it like that, square both sides like that. Then kinali x squared equals to what? R squared. But you know what is R squared? R squared ki x squared plus the y squared. Do you remember that?